We have spent a few weeks discussing the purpose of collecting and storing large amounts of data, and we talked about how the analysis of that data can be beneficial for a lot of different purposes. We also spent some time discussing the high-level ideas behind a data warehouse, and this week we will dig a little deeper into the technical side of how to design a data warehouse infrastructure. Now, this is no small undertaking, and a significant amount of planning should go into each piece. There are a few key variables that need to be determined when planning out a data warehouse. The first is to identify and collect requirements. Think of this like designing a new piece of software. Software design has a long-standing development model that steps through different phases to make sure everything needed is included. Designing a data warehouse should take a similar approach, and in this first step we need to sit down with the decision makers to determine what they need. This may be one of the most critical phases. No one wants to go back and redesign an entire architecture because they forgot about a need that needed to be satisfied by the system. So the leaders need to determine how they want to analyze the collected data and the business questions that need to be answered by the analysis. If we use a business as an example, there are some specific requirements to consider. How often store profits should be analyzed will help determine the types of queries needed and the type of applications that will be required to review the results. You may need to consider how often the profit and sales data should be reviewed, and if it should be looked at several times each day, once a week, or within any other tolerances that management feels is important. Specific information on products should also be considered. Supply and demand is a constant in business, so being able to analyze which products are selling quickly and which ones are sitting stagnant on the shelf would probably be a priority. Trend analysis is something almost all data warehouses are used for, and in this case, being able to study sales data over periods of time can help determine peak sales times so more employees can be on hand to make more sales. I would also be good to look at times of day that have the highest sales for the same reasons. A restaurant, for example, knows that their peak times will be during the 3 major meals of the day. Bars know that the after-work period is going to be the biggest rush. And department stores know that the after Thanksgiving sales will draw the largest crowds. Finding these peak periods for a specific business would be a major benefit. One other comparison that may be required is to track annual sales from year to year to help determine overall gains or losses, and to be able to project future gains or losses. This is information prospective investors will want to know about before they buy stocks, so including this on the list of requirements would also be key. Now take a few minutes to think about other requirements that may be worthwhile in this example, or even take some time to think about the requirements needed in some other example of your own. This type of requirements listing will help to determine the needs in other areas of the design plans. Next, we need to develop a dimensional model that can be accessible by users who will be conducting the analytics. This model should be designed so that it can be extended and expanded as future unanticipated needs come up. Company growth will always require growth in some areas, so it is important to plan for that growth. Dimensional modeling is a technique where the dimension is the master database table that contains the individual data elements such as names, identifiers, and information. Essentially, the data fields you would normally find in a database. Now, think of the dimension as a master table, and in our business example, we would probably see data elements like product, store, customer, sales employee, date of sale, and time of sale. Our model will also need to include measures or columns of quantifiable data. Now, that can be combined together. These are typically numeric fields that could include total number of sales, cost of product, and the quantity sold. One other measure that should be included would be a fact table. Fact tables provide the statistics that can be separated out by the salesperson, product, customer, and period of time. Now, this dimensional model is one more piece of information in the foundation of the data warehouse design. It can't be overstated that we need to methodically think through each design element and each requirement to make sure the final product performs in the needed way and provides the users and managers the information needed to make the decision that will determine the future of the organization. Spending extra time in this process is never a bad idea. Next up, we need to design the relational database. Now, you should have some database experience if you are in this course, so this section will be very familiar to you. We'll need to come up with a schema for the database, and some of the more popular ones are star, snowflake, and the starflake schema. A star schema is similar to the star topology in networking. It has a table at the center with points connecting out to each of the other tables. The snowflake schema is similar to the star model, except that the tables connected to the center also connect out to other tables, and those tables continue to connect outward. And a starflake schema is a blending of both of these that allows certain dimensions to be snowflaked. I encourage you to look at the diagrams in your textbook or search online for the images of these schemas so that you will have a good visual. Now, we won't get into a discussion here about which schema is better because they all have their own pros and cons, and many times the one chosen is selected because the designers are most familiar with it or because it has a specific capability they want to employ. At any rate, once the schema is selected, we can move on to the next piece of the design process. Our next step is to populate the tables with some data. There are a few different ways we can go about this. One method is to use SQL scripts to populate the tables with a lot of test data. Now, this is a good idea because it will give analysts a chance to write and test queries before the warehouse goes into full production, and it also gives time for other necessary tests like stress testing processing power, data transmission rates, and the amount of time it takes for complex queries to be completed. Creating custom reports using the test data is also a good way to let managers decide what visuals they would like to receive as part of any regular reporting requirements. Another avenue that can be taken is to skip the test data and move right into populating the tables with historical data from transactional databases. The same types of tests can be run against the historical data, and it may even yield more accurate results since the users will be working with the same type of data that will be available when the system is in full production. Either method will work fine, and it is ultimately up to the design team to decide the avenue they want to take. One thing I haven't mentioned yet is the need to determine the actual physical storage requirements, the type of software and hardware needed, and the amount of building space that will be required to house these systems. Smaller businesses can get away with a few servers and a lot of storage capacity, but much larger organizations will need to plan for some actual real estate that can house a large data center. I mentioned in an earlier lecture that Facebook has a data warehouse capable of storing 30 petabytes worth of information. I guarantee you that the space needed to store the system's housing, operating, and managing this warehouse is quite large. So it is something else that needs to be considered and will be primarily based upon the amount of data expected to be collected each day over a large period of time. It will also need to be expandable as the organization grows. Now, you can also consider using a cloud infrastructure instead of managing your own data center. Companies like Amazon offer up storage and processing power on their systems that could be used for this purpose, but the fees may be too high if there is a lot of data, so a cost analysis would need to be conducted. By this point in the course, you should have a good understanding of big data, how to analyze the data, and how to design the data warehouse so that all of this data can be useful. I've covered some of the design pieces at a little more depth than usual, so that you have a really good understanding of how these warehouses are created and all the thoughts that need to go into the design process. Now, this will come in handy in the last few weeks of class as you work on the final project and develop your own data warehouse. So, after this week's lecture, you should have a good grasp of the design process that identifies requirements, develops a dimensional model, designs a relational database, populates the tables with data, and determines the physical storage requirements. Our next lecture will focus on the challenges commonly encountered when using data warehouses.